Hello and good afternoon to everyone in our Facebook and Zoom platforms. Welcome to today's webinar entitled Is There Gold in Golden Rice? Addressing Vitamin A Deficiency Through Biofortification. I am Ana Aurelio and I will be your moderator for this afternoon. So here are some reminders before we begin. This webinar will be recorded for documentation purposes. For questions, you may use the Q&A function at the bottom right side of your screen, and please include your name and affiliation when posting a question. These will be answered at the end of the lecture. You may also want to raise your hand. So again, don't forget to mention your name and affiliation before you ask your question. If you encounter any connectivity issues, please click the reconnect button at the top of your screen. Certificates will be made available after filling out the evaluation form. So do stay tuned until the end of the program. The link will be sent on both Zoom and Facebook. So now let us pause for a moment as we open this event with a prayer and the singing of the Philippine National Anthem. Formally open our program, it is an honor to present to you the Chancellor of the University of the Philippines, Los Baños, to deliver his welcome remarks. Together, let us warmly welcome our dear Chancellor, Dr. Jose B. Camacho Jr.
To our guest speaker, Dr. Amanda Palmer of the Johns Hopkins Bloomberg School of Public Health. To the Senior Programs Manager of Helen Keller International, Ms. Maria Fatima Dolly Riario. To the Dean of the College of Human Ecology, Dr. Ricardo Sandalo. To the Director of the Institute of Human Nutrition and Food, Dr. Amy Cherie Barion. To our faculty members, reps, administrative staff, students, and alumni, and to all our participants, good afternoon. I am happy to address you today for this webinar entitled, Is There Gold in Golden Rice? Addressing Vitamin A Deficiency Through Biofortification. This webinar will touch on some of the most pressing themes that the world faces today: food security, health and nutrition, and the use of bioengineering as a solution to the two prior issues. With rice being such a staple food crop for us Filipinos, it cannot be denied that it's very fortified with essential vitamins and minerals would be a boost in combating hunger and malnutrition. Golden rice, a technology that has been around since the 1990s, is one such solution. However, misinformation and ignorance has led to unfavorable reception of such innovations to some segments of the general public. Today's discussion on golden rice will hopefully enlighten our participants on its benefits and why it should be seriously considered as part of the solution to eradicate nutrient deficiency, especially in developing nations, where a significant segment of the population consumes rice. I commend the Institute of Human Nutrition and Food of the College of Human Ecology for their initiative in conducting informative and relevant webinars such as this. I'm also grateful to the Helen Keller International and Johns Hopkins Bloomberg School of Public Health for collaborating with us in this learning activity. Information dissemination such as this will help us fulfill our goal of making our activities relevant to the needs of our communities as articulated in our rebranded research and extension agenda called the UPLB Agora, which stands for Accelerating Growth Through One Research and Extension in Action. This conversation is aligned to the UPLB Agora pillars on food, security, and sovereignty, and One Health, areas where we wish to further contribute on, not only to fulfill our mandates as the national university, but also to do our part in fulfilling the Sustainable Development Goals set by the United Nations. I enjoined our participants to listen attentively in today's webinar, to ask questions, and to share your learnings with your circles of influence so that misconceptions about useful technologies such as the golden rice will be corrected. Thank you very much and stay safe. As we say it here in the Philippines, mabuhay.
Thank you very much to our dear Chancellor. And we thank you too for allowing the Institute of Human Nutrition and Food to host this event. This event will not be possible without our kind partners from Helen Keller International. So let me call on the Vice President for Nutrition of Helen Keller International, Dr. Rolf Clem, to give us a message. Dr. Clem.
So magandang hapon sa inyo lahat. Hayaan muna akong magpasalamat kay Chancellor Jose Camacho, Dean Ricardo Sandalo, Director ng Institute of Human Nutrition and Food, Dr. Amy Sherry Barion, sa pag-imbita sa amin sa kaganapan. Gagawa ako apat na puntos sa aking pagbati. So I'll make 4 points during my welcome remarks. The first point is that we stand on the shoulders of giants who have come before us. And speaking personally, malaki ang utang na loob ko sa Pilipinas at sa mga public health nutrition luminaries who I am honored to call my mentors and who've inspired me. The late Dr. Florentino Salon, at ang kanyang partner na si Mercedes Salon, Dr. Rodolfo Florentino, Dr. Corazon Barba, who is well known to UPLB, Dr. Demi Bonga, Susie Limbo, Dr. Cecilia Florencio, Mrs. Adelisa Ramos, at maraming iba pa. Okay, naubos ko ang Tagalog ko, so I will switch to English. So for my second point, we are experiencing challenging times that are making it very difficult for everyday Filipinos to survive, let alone thrive. 2 years under COVID, travel and gathering restrictions have stressed the lives and livelihoods of so many of us and have upset food supply chains, driving the cost of nutritious foods higher and higher and rates of malnutrition higher. These stresses are exacerbated by the outbreak of war in Ukraine, driving fuel and food costs even higher. And finally, each of these is being played out in a world made hotter by greenhouse gas emissions and the negative consequences of climate change. These challenging times call for leadership, expertise, and a recommitment to UPLB's mission, namely to develop human-centered, self-reliant, and ecologically stable communities to meet basic human needs, including nutritious foods for all Filipinos. So my third point is actually a question. So what do these challenges and a call to reinvigorate UPLB's mission have to do with golden rice? Does golden rice have the potential to play a role in creating self-reliant and ecologically stable households and communities? Put another way, and to borrow the title from Dr. Amanda Palmer's talk, is there gold in golden rice? If so, where is it? And how will we know? I don't want to steal thunder from Dr. Palmer's talk, but my plea to you is to keep an open and critical mind. As you know from the resistance towards COVID vaccine, misinformation, exaggeration, and fear of the unknown can create resistance and controversy and can prevent people from availing of a life-saving vaccine. So my plea to you with respect to golden rice is to be informed and play your role in countering misinformation. My fourth and final point comes from a saying that goes, all that glitters is not gold. What does that mean? It means that not all things that are new and shiny are as valuable as they seem. They need to be examined and tested objectively to assess their true value. And this brings me back to the catchy and provocative title of Dr. Amanda's talk, Is There Gold in Golden Rice? As some of you know, Helen Keller International has teamed up with the Johns Hopkins Bloomberg School of Public Health and colleagues in the Philippines to examine the potential benefit of golden rice to the nutritional health of Filipino children. Some of you have heard of Helen Keller, the woman. She overcame adversity of being deaf and blind at 2 years of age to become one of the 20th century leading humanitarians. And she once said, life is a daring adventure or nothing. Golden rice has been a daring adventure in terms of misinformation, myths, and controversy. Yet the Philippines has not been daunted and has led the way by approving it as safe for human consumption and approving it for commercial propagation. But will it improve the nutritional status of children? That is the question being posed by Dr. Amanda's talk. So sit tight and let the daring adventure continue. Maraming salamat.
Maraming salamat po, Dr. Clem. Indeed, we have a very interesting topic this afternoon. So what Dr. Clem mentioned, we are at the forefront of food and nutrition security at this time. We have hidden hunger. Vitamin A deficiency remains to be a public health concern. And for today, we will be listening about the biofortification of our staple crop, rice. So once again, the IHNF is truly honored to be partnering both with Helen Keller International and Johns Hopkins Bloomberg School of Public Health for today's event. To introduce our speaker, let us all welcome the Senior Programs Manager of Helen Keller International, Ms. Maria Fatima Dali Reario. Ma'am Dali?
Good afternoon, online participants from different platforms. It is my pleasure to introduce to you our speaker for this afternoon. Our speaker holds master's and doctoral degrees in human nutrition from the Johns Hopkins University, Baltimore, Maryland. She has 20 years of experience working on nutrition research, policy, and programs in low and middle income countries. Her primary focus has been the control of micronutrient deficiencies through supplementation, food fortification, biofortification, and dietary change. From her works, she has numerous publications as well as presentations in scientific meetings. She has worked previously with the UNICEF, Helen Keller International, and the Peace Corps. She has been a principal investigator for various researches on infant growth, vitamin A, beta-carotene, fortification, and biofortification, which includes the Golden Rice Nutritional Impact Study. Currently, our speaker is an assistant professor in the Department of International Health at Johns Hopkins Bloomberg School of Public Health. Ladies and gentlemen, let us welcome Dr. Amanda Palmer.
Thank you, everyone. I'm going to go ahead and share my screen. Okay, so good afternoon, Chancellor Camacho, Dr. Clem, Director Barrion, and all of the participants in today's seminar. I'd like to thank the organizers from the University of the Philippines, Los Baños, and Helen Keller International for the opportunity to speak to you today. I'm really pleased to be here. I'm going to be sharing some of the research that's gone into the development of golden rice, and I'll also share our plans for an evaluation of its impact on vitamin A deficiency. Some of what I'll show you today represents the work of colleagues at the Philippine Rice Research Institute, the International Rice Research Institute, and others. They're leading the development of the product as well as its deployment. The nutrition evaluation is a collaboration between Helen Keller International, the Philippine Food and Nutrition Research Institute, and Johns Hopkins University. So as we have a diverse audience today, I thought I'd start with a quick review about vitamin A. So as many of you will know, vitamin A is an essential micronutrient. And what that means is that our bodies cannot synthesize vitamin A. So we need to get it in small amounts from our diets. While it has a number of different functions, it's particularly important for visual function and to support the immune system. And as I show here on my slide, we have two types of dietary sources. Preformed vitamin A is generally found in animal source foods, and liver is an excellent source because this is where animals store vitamin A. I also show egg yolks and milk, including breast milk, are the other important sources. Preformed vitamin A is also used in the manufacturing of fortified food products. And I should say that our bodies can efficiently absorb it, use it, or store preformed vitamin A. On the other side here, I have provitamin A carotenoids in fruits and vegetables. An example here is beta-carotene that we're going to talk about throughout this talk. And we're able to convert provitamin A carotenoids into the active forms of vitamin A. But there are a number of factors that influence that process, and I want to cover here. For example, dark green leafy vegetables, as we all know, a source of provitamin A carotenoids, they have a relatively complex food matrix, and this makes it difficult for the body to access carotenoids. So we call this bioaccessibility, and it's higher in yellow or orange foods like papaya, and cooking methods also play a role here. So the absorption of carotenoids also varies. It can be facilitated by consuming carotenoids with added fat. Intestinal helminths, on the other hand, have the opposite effect. They can inhibit the ability to absorb carotenoids. And finally, whether the body converts beta-carotene to retinal will depend on an individual's vitamin A status. It's only converted when we need it. There are also genetic polymorphisms that can alter how efficiently individuals bioconvert carotenoids. So we're talking about vitamin A deficiency today. Why is it that children become vitamin A deficient? So first off, all infants, regardless of where they are in the world, are born with low levels of vitamin A. They rely on their mother's milk to build their stores. And if a mother has inadequate vitamin A in her diet, her breast milk may have a low vitamin A content. Sources of preformed vitamin A can be expensive, and they're often not included among complementary foods. Furthermore, infants or young children do not or they cannot consume enough carotenoid-rich sources. And finally, infants and young children are constantly exposed to infections. These can draw down on a child's vitamin A stores at a time that it's most needed to support the immune system. So in the Philippines, an estimated 15% of preschool-age children are vitamin A deficient. So the country is classified as having a moderate public health problem by the World Health Organization. That being said, provincial estimates vary widely. In parts of the country, vitamin A deficiency is found in 20 to 30% of young children. And in a few areas, the prevalence actually exceeds 30%. And the data indicate that children in poor, usually rural areas, are at greatest risk. So what does it mean to be deficient? Well, many of you already know that vitamin A is important for the eyes, and specifically it's needed by the rod cells at the back of the eye that enable us to see in dim light. And children with severe deficiency, they can experience what we refer to as night blindness. And as deficiency becomes more severe, children can develop xerophthalmia, and you saw the pictures of that earlier. This can range from abnormal patches or dryness on the surface of the eye to corneal ulcers or a softening of the cornea, which we refer to as keratomalacia. And these are very severe forms of deficiency, and they're quite rare, but they can result in corneal scarring, which is the picture that I'm showing here. And this is why vitamin A deficiency is considered the leading cause of preventable childhood blindness. I want to stress again that these are very severe forms of vitamin A deficiency. They're quite rare, but they're really the tip of the iceberg here in this figure on the right. But even without these clinical signs, there may be inadequate vitamin A in the tissues or in the blood. And this can have functional consequences like a weakened immune system. So you'll see across this full continuum of deficiency, we see an elevated risk of children dying from infections like diarrhea or measles or malaria. And it's because of this risk of death, particularly in young children, that there's such a strong commitment to preventing vitamin A deficiency. We have multiple strategies to do this, and I'm going to focus on supplementation first because it's somewhat of a special case. When we talk about supplementation, we generally mean providing a large dose of vitamin A to young children every 4 to 6 months, usually as part of a campaign. And the purpose of vitamin A supplementation is to build up children's stores for a period of time. And what this does is it offers protection against those effects on the eye that I just showed you, as well as severe morbidity and mortality. I say that supplementation is a special case because it doesn't address the underlying issue of an inadequate diet. And that's where the other strategies are key. So first off, dietary diversification is really our goal. And for vitamin A, that means increasing the consumption of carotenoid-rich fruits and vegetables or of animal source foods. And for example, I'm showing here small dried fish that are consumed whole, including the liver there. The fish store the vitamin A. And I don't have a picture here, but appropriate breastfeeding practices are also critical. The next strategy is food fortification, and that's whether it's done at the industrial level, like with margarine here in the Philippines, or in the home with micronutrient powders that can be added to complementary foods. And finally, we have biofortification, which I'm going to discuss in more detail. But together, the preventive strategies, they're sometimes shown as puzzle pieces because they're intended to work together. And the reason for that is we need multiple strategies to achieve vitamin A deficiency control. We can't just choose one of these, they need to work together. So biofortification, this involves improving the nutritional quality of food crops. And usually when I talk about this, the first thing that comes to mind is GMO. It always comes up in conversations, but really there are several different methods to achieve this. The first of these is agronomic biofortification. This is used almost exclusively for minerals, where the nutrient content of crops is heavily dependent on the mineral content of the soil. One strategy here is to apply mineral-rich fertilizers. So these could be added to the soil, or they could be directly sprayed onto leaves. So agronomists generally use these fertilizers because crops also require nutrients to grow, and their focus is on increasing yield. But these mineral-rich fertilizers can also increase the allocation of nutrients to the edible parts of plants. There's been some success here with potassium iodide, with zinc, and with selenium. Another option in agronomic biofortification is the use of inoculants, and these are microbes that form a symbiotic relationship with target crops. And they can be used alone or in combination with fertilizers. So when they're used alone, certain microbes added to the soil can actually assist the plant in nutrient uptake. So that's one strategy. The next approach is actually the most common, and that's conventional plant breeding. This method takes advantage of wide natural variability in the nutrient content of some crops. And sweet potatoes are a perfect example here. There are white varieties with little to no beta carotene, and there are bright orange varieties with greater than 200 micrograms of beta carotene per gram, and that's very high. In beans, we see wide genetic variability in iron concentrations. Some of that's due to differences in uptake from the soil, but there are also differences in phytate content, which inhibits our ability to absorb minerals. Finally, biotechnology can be used to improve the nutritional profile of crops. On the left here, I'm showing gene editing, which allows researchers to make highly targeted changes to a plant's genetic code. And most gene edits make changes to existing DNA rather than introducing new genetic code. And it's done using sequence-specific nucleases, which are sometimes referred to as molecular scissors. Many of you in this audience have probably heard of CRISPR, which is the most commonly used method for gene editing. Finally, there are transgenic methods, and this involves the modification of a host plant through the exchange of genetic materials. So for example, inserting genes from another species. And the best example of this in the field of biofortification is golden rice. As I mentioned before, there have been multiple partners involved in the development of golden rice. Here in the Philippines, that research has been led by scientists at the Philippine Rice Research Institute. So in this part of my talk, I want to provide some background on the development of golden rice, and I really want to acknowledge here the team at PhilRice who've done much of this work. So biofortification of the vitamin A crops is tied to this carotenoid biosynthesis pathway, and the provitamin A carotenoids are shown here in orange. So for rice, the leaves produce and accumulate beta carotene by this pathway. But difference between rice and the other biofortified crops is that in the rice grain, the pathway stops at this geranyl-geranyl diphosphate here at the top, that I've indicated with the green arrow. And that means that there's a complete absence of provitamin A carotenoids in the part of the plant that we eat. So the developers of golden rice used a method called agrobacterium-mediated transformation, or AMT. And AMT relies on the natural ability of a common soil bacterium to alter a plant's genetic makeup. They use this method to introduce a transgene or recombinant DNA that codes for two enzymes, and the first of these being a phytoene synthase, and the second is a carotene desaturase, which substitutes for the activity of what would be these multiple plant enzymes in the pathway. The introduction of this transgene is referred to as an event, and in this case, it's the GR2E event, where rice can have between 20 to 30 micrograms of carotenoids per gram at the time of harvest, and most of this is beta carotene. The most common question we get about golden rice, and many of you in the audience have this very question, is whether it's safe to eat. And the short answer to this question is yes, it absolutely is. So regulators in multiple countries have reviewed an extensive portfolio of scientific evidence here. And the outcome in all of these countries has been consistent, that the safety profile of golden rice does not differ from that of ordinary rice. The only discernible difference is in the presence of beta carotene. Here in the Philippines, the Department of Agriculture's Bureau of Plant Industry holds this regulatory authority, and they approved golden rice for food, feed, and processing back in 2019. Because safety is such an important issue, I want to talk a little bit more about the safety review process. I'm showing this this manual here on the right that was put out by the WHO and the FAO. And what it is an internationally agreed upon regulatory framework that's used to assess the safety of transgenic crops. It's part of the Codex Alimentarius. So the underlying question that developers of a product need to answer is how a genetically modified food compares to its conventional counterpart. And I want to walk you through these 4 summary components, which are the host plant, the donor organisms, the expressed proteins, and any nutritional modifications. So first, the regulators look at the plant that's being modified and its usual use as a food. In this case, it's rice, which has a clear history of safe use in being the staple food for more than half of the world's population. And the species that was modified in the case of golden rice is already widely cultivated. There are thousands of cultivars available in more than 100 countries. So while rice is most often consumed either boiled or steamed, there are also a number of products available on the market. So things like puffed rice, for example, or products made from rice flour. And finally, we know that rice is not commonly allergenic. Those allergies are very rare. So again, there's a clear history of safe use here. The second focus of the regulatory reviews are the donor organisms. And golden rice involved the insertion of these 3 genes that you see on the left. The first 2 of these I mentioned as part of the carotenoid biosynthesis pathway. So the donor for the Cy1 gene is maize. And again, just like rice, there's a long history of safe use. It's the world's dominant staple crop. The CRTI gene was donated by a soil bacterium that affects a wide range of food crops. And while there's not an established history of safe use here, we do know that the CRTI gene is not involved in any pathogenicity or virulence of the bacterium. A third modification was the insertion of this PMI gene, which is often used as a selectable marker in transgenic crops. And the donor organism here is a strain of E. coli, which has an established history of safe use. So for example, it's used in protein production systems for things like pharmaceutical products or food ingredients. I should note, they're not on this slide, but there are 2 other donor organisms, both of which are commonly used in the agrobacterium-mediated transformation. So again, their safety has been well established. The genes on the prior slide yield these 3 proteins that are expressed in golden rice, but not in conventional rice. So these are considered novel proteins, and they are the phytoene synthase, the carotene desaturase, and the PMI protein. So I want to walk through the safety review steps. So to evaluate the safety of these proteins, developers first rely on bioinformatics. They search extensive databases of known protein toxins or of allergens to see if there are any similarities in amino acid sequences. So for the phytoene synthase, there were no sequence similarities across those databases. For CRTI, there were some minor similarities, but these were in a region of the enzyme that is both insufficient for function and commonly found in other non-toxic proteins. So it's not considered an area of concern. PMI had a minor sequence similarity to a known allergen. So it actually underwent additional testing using serum from an individual known to have this allergy. And they found no reactivity in this test. And what that tells us is that the sequence is not biologically relevant. So where there are any concerns in the safety testing or in the sequence similarities, proteins can then be tested in animals. So this was unnecessary for the phytoene synthase because there were no sequence similarities. For CRTI, the sequence similarities really weren't found to be of concern, but since the protein was from a non-food source, the developers proceeded with animal testing. And here they found no evidence of toxicity in mice. As the PMI gene has been used in other transgenic crops, there were actually existing animal studies that showed no adverse effects. So what's further important here is that all three of these proteins are denatured by heat. So with normal processing and cooking, the dietary exposure would be negligible. And finally, in vitro testing has demonstrated that all three proteins are also rapidly digested. Taken together, regulators agreed that these proteins are unlikely to be harmful to human health. But finally, we need to consider whether there were any unexpected changes to the food that might have altered its nutritional adequacy. So there were extensive compositional analyses that were carried out to look at both nutrients and at anti-nutrients. And here I'm showing you just the proximate composition and a few micronutrients, but really across all nutrients and anti-nutrients that were tested, there were no unexpected differences between golden rice and ordinary rice. The only difference was the anticipated change in the carotenoid content here. The concentrations were lower than the limit of detection in ordinary rice versus 4 to 10 micrograms per gram in golden rice at 2 months post-storage. I'm going to come back to that storage issue in a little bit. I want to address one last question, and that's related to the risk of nutrient toxicity. But consuming even large amounts of golden rice will not lead to an overdose of beta carotene or vitamin A. Usual consumption of beta carotene from the diet is safe. As some of you may have heard of hypokeratinemia, which manifests as a yellow to orange pigmentation of the skin. It's due to high carotenoid consumption, but is a benign and it's a reversible condition. And there's also likely to be a genetic component. Unlike carotenoids, vitamin A can be toxic in high amounts, but that's preformed vitamin A and usually from supplements. Our bodies cannot make too much vitamin A from carotenoid food sources. This is because the activity of the carotenoid cleavage enzyme, BCO1, is downregulated when vitamin A status is adequate. So we only convert what's needed. Combining all of this information, we can be confident when we say that golden rice is a safe food. In addition to its approval for human consumption, back in last year, the Philippines became the first country in the world to approve golden rice for commercial farming. So to touch on that briefly, golden rice has been bred using rice varieties that are common to the Philippines. And the research compiled for regulators demonstrates that there are no differences between golden rice and ordinary rice for any of the factors that I've listed here. I especially want to emphasize yield and production costs, as those are very common questions. The aroma, the texture, and the taste of golden rice are also comparable to ordinary rice. It's just the beta carotene, which is a natural pigment that gives the rice grain its characteristic golden color. As I mentioned, golden rice received approval for commercial propagation in 2021. In terms of its readiness for market, developers still need to seek varietal registration with the National Seed Industry Council. But this is based on good agronomic field performance, which has already been demonstrated. So over the next few years, PhilRice and its partners will focus on seed production, and they'll also begin the deployment of both seeds and milled rice in areas of the Philippines with an elevated prevalence of vitamin A deficiency. Starting in 2024, deployment will also be expanded through markets and through program-based approaches. There's a brief on deployment plans from PhilRice that we've included in the documentation for this webinar. I've also included a QR code at the end of the presentation so that you can access additional information. In the second part of my presentation, I want to focus on the potential nutritional impact of golden rice. I mentioned that I'd come back to this a little earlier. Studies in the Philippines on beta carotene content are still ongoing. So these are data from the trials in Bangladesh, and they illustrate what we know about carotenoid retention in rice. So the carotenoid carotenoid content is highest at the time of harvest, and the greatest losses occur during the first couple of months of storage. The upper line here is showing the retention of carotenoids in unparboiled rice. So that's similar to what we'd see with rice production in the Philippines. But again, we see the significant drops in the first 2 months of post-harvest, and then the concentration of carotenoids tends to plateau, and there are minimal losses during cooking. So the carotenoid levels at the time of consumption are similar to what we see with the other vitamin A biofortified crops. What does this mean for dietary intakes? So there are a number of carotenoid-rich foods already in the diets of children in the Philippines, and you'll often hear this comment when we start talking about golden rice. But rice is the major contributor to daily caloric intake. It also has an easily digestible food matrix, so the carotenoids in golden rice can be efficiently absorbed and can be converted into vitamin A. And usual rice intakes are high enough that golden rice can provide about 1/3 to 1/2 of the estimated average requirement in young children. And that's in a food that the population is already consuming every day. So again, there are numerous carotenoid-rich food options in the Philippines, and I'm showing here Kong Kong, for example, that has a much higher carotenoid content than golden rice, but it's also a much more complex food matrix. There's some research on pureed and cooked dark green leafy vegetables, and that shows that the vitamin A equivalence of carotenoids from dark green leafy vegetables is about 21:1, and that's compared to about 4:1 in golden rice. So to get the same amount of vitamin A from green leafy vegetables, a child would need to consume 4 cups of cooked kangkong, which is roughly equivalent to 12 cups of raw leaves. And I want to stress that to improve vitamin A intakes, we really need multiple food sources, and golden rice has the potential to be one of those sources. So we know about the potential contribution of golden rice to vitamin A intakes. What we don't know is whether regular consumption of golden rice by children at risk of deficiency will improve their vitamin A status. We have good reason to believe that this would be the case, but it remains a hypothesis that we need to test. And that's the goal of our nutritional evaluation. Now, ideally, our research would be carried out among those at greatest risk of vitamin A deficiency. And in the Philippines, this problem is largely limited to children and young children. The available biochemical data, which are that 15% prevalence that I cited earlier, is from infants and children less than 5 years of age. But this age group is also targeted with high-dose vitamin A capsules twice each year, which complicates our ability to carry out research in this age group and also specifically to interpret findings related to vitamin A status. I want to note that while we don't have biochemical data on older children, there are dietary data available, so we can look at dietary inadequacy. And you'll see that the prevalence of dietary inadequacy is still quite high, even in somewhat older children. Over 60% of 6 to 9-year-olds are consuming less than the estimated average requirement. The first step in our research will be to collect biochemical data in this age group. And where we're at right now is collecting data or carrying out scoping activities to determine where our research should take place. And this is involving a review of proxy indicators of vitamin A deficiency, which I've listed here. So for example, stunting prevalence or prevalence of food insecurity or poverty. There are also data from the National Nutrition Survey on vitamin A status in younger children. We also want to consider populations that have the potential to benefit from golden rice. So this needs to be in rice growing areas, and particularly those targeted for golden rice deployment. And finally, we'll need the strong support of community members to carry out this research. So we're currently in the process of conducting site visits to meet with officials in multiple sectors and to talk with community representatives. And our goal here is to carry out a screening study in 2 provinces to help us determine where the nutrition evaluation study would be fielded. In terms of the trial's intervention arms, again, our question is whether golden rice improves status relative to ordinary rice. And to do this, we'd be feeding children over a 90-day period. The meals would be delivered at school as part of an expanded school feeding intervention. And this here is our primary comparison. Again, the golden rice versus ordinary rice. But what we're proposing is actually a 3-armed trial with a positive control arm, which is the gold standard of any experimental design. It helps to assure the validity of the trial, but importantly, it also enables us to do a non-inferiority analysis so we can compare golden rice versus an equivalent amount of preformed vitamin A. As you see at the bottom here, the preformed vitamin A would be delivered in the form of a low-dose supplement. The inclusion of a positive control arm also enables us to calculate the vitamin A equivalency of golden rice. So we have that estimate, or the estimate of 4-to-1 vitamin A equivalency that I mentioned earlier, but that research was carried out among adult volunteers in the United States, and we want to see if that equivalency differs among high-risk children in a poor area of the Philippines. To give you some sense of what a feeding trial entails, I want to show you some pictures here of a trial that we did in Zambia, which was a 6-month-long feeding trial of biofortified maize. And you can see it's quite a logistical challenge to do a trial like this. The first picture here are cooks who are preparing meals according to standardized recipes. And then children come to the site. In this case, we were feeding younger children, and they're assisted in washing their hands with soap and water. The cooks are at the same time weighing out standard portion sizes of the staple food and of the relish that went along with the maize. Again, it's quite an undertaking with lots of logistics, but the children are then served in their assigned numbered bowls, and they're free to consume as much as they can of the maize in this case. And then the cooks weigh the leftovers and they record the attendance and the leftovers. So this particular trial enrolled over 1,000 children. So again, while it's a logistical challenge, it is feasible. This is the type of study that we're proposing for golden rice. In terms of the golden rice trial, I'm dividing here between interviews and clinical assessments. So these are the data and the samples that we will be collecting. And the interviews would be conducted in all children at baseline, or children and families at baseline and end line, as well as those daily compliance data from the feeding intervention that I mentioned. And in a subset of children, we'd be collecting repeated data on diet and morbidity using a 24-hour dietary recall and a 7-day morbidity questionnaire. For the clinical assessments, where we have anthropometry, we've got a venous blood draw, and at baseline, we would deworm children. I mentioned in the earliest slides that intestinal helminths can affect a child's ability to absorb carotenoids. And in a subset of children, we take a finger prick blood sample on the first visit to test for C-reactive protein, which is a marker of inflammation, and then we dose children with a stable isotope of vitamin A. Then 4 to 7 days later, we'd return to take a venous blood draw for the analysis of isotope enrichment. And at end line, we repeat the same assessment, at the clinical visit. We have a series of study outcomes. And first off, golden rice contains beta carotene. So if the beta carotene is efficiently absorbed, we'd be able to detect this in the serum. And this is something that we can measure by high performance liquid chromatography. At the same time, we'd measure serum retinol. Serum retinol is the most widely used measure of vitamin A status in nutritional status surveys, including the National Nutrition Survey. And serum retinol concentration below a cutoff of 0.7 micromoles per liter is the primary indicator of population status. It is readily interpretable by program managers and by policymakers. The figure here on the right shows a distribution of serum retinol concentration prior to the start of an intervention. And you can see that some portion of children are falling below that 0.7 micromole per liter cutoff, so they'd be considered deficient. Now, what we'd expect to see with a dietary vitamin A intervention is a shift in this distribution to the right. And the figure here gives an example of that. These particular data are the shift in serum retinol that we're seeing before and after the introduction of a fortified food product. So we'd be testing for this same shift in the mean of the distribution of serum retinol. This is our primary outcome. There are a number of challenges in interpretation of serum retinol concentration, the first being that it's homeostatically controlled across a broad range of status. So in a population with moderate status, we might expect to see an impact only in that lower tail of the distribution, in which case we could focus on a change in the proportion of children falling below that 0.7 micromole per liter cutoff. And this is actually one of our secondary outcomes. Can we have an impact on the prevalence of deficiency? A separate challenge in interpreting serum retinol concentration relates to infections. So retinol binding protein that circulates with retinol in the blood is actually a negative acute phase reactant. That means that it's sequestered in the liver as part of an inflammatory response. The figure on the right here shows what this means for the concentration of serum retinol, which is indicated with the gray line. So in the earliest part of an acute phase response, we see this sharp spike in C-reactive protein, which is the green line, and a steep decline in serum retinol concentration. And as the inflammatory stimulus is cleared, there's a shift from CRP being the dominant acute phase protein to the alpha-1 acid-glycoprotein AGP becoming elevated. We start to see serum retinol concentration rise again during this convalescent period, but it doesn't reach its starting concentration until much later. This particular figure is based on data from orthopedic surgery patients, so it doesn't fully reflect what we'd expect to see among children commonly exposed to infections or a harsh environment. In that case, there'd be spikes in these proteins during an acute infection, but they're also likely to be chronically elevated, and that can similarly influence serum retinol concentration. So how we handle that is there are statistical methods available to adjust serum retinol concentrations using the concentrations of CRP and AGP. So what we'll be doing in our analysis was we'll present the impact on both unadjusted serum retinol and unadjusted serum retinol concentrations. Finally, to assess total body stores of vitamin A, we'll be using a retinol isotope dilution method. And this involves the oral administration of a stable isotope, not a radioactive isotope, a stable isotope of vitamin A. And basically, we give a dose of the isotope, and at the same time, we measure CRP because the elevated CRP can affect our ability to absorb vitamin A. So then we would allow the labeled vitamin A to mix with the body store, the body pool, and come back 4 to 7 days later and take a venous blood sample. So for the analysis, we would use an LC tandem mass spec to measure the concentration of labeled to non-labeled vitamin A. And it's the ratio of these two that enables us to model total body vitamin A and then to calculate vitamin A liver stores. So our sample size is going to be somewhat dependent on the results of our scoping activities and our screening study, but I wanted to give you some sense of the size of the trial. As I said, mean serum retinol is our primary outcome. We're looking at a change in the mean. So we're calculating this based on an anticipated 0.07 micromole per liter difference between the groups. And this is a meaningful difference. And it's actually comparable to the effect size that we saw in a trial of orange flesh sweet potato that was carried out in Mozambique. So what this yields is a sample size of 400 per group in the golden rice and in the negative control arms. So this is not an infeasible sample size. Like I mentioned earlier, the trial we did in Zambia had over 1,000 children. But given this estimate of 400 per group, we'd also be able to detect a 10 percentage point reduction in the prevalence of vitamin A deficiency in the golden rice arm versus the negative control. Now for total body stores, this is a much more complex, both assessment and analysis. So for these, our preliminary calculations suggest that we can anticipate a 2.5 milligram change in body pool size. For this, we need a sample of about 100 per group in each of the 3 arms. So overall, there would be 400 participants in the negative control, 400 in the active arm, and then 100 in the positive control arm. So our total sample size would be about 900 children. A final issue that I want to touch on is research ethics. We know that children are a vulnerable population, especially those in underprivileged areas. So we've really been thinking through how to strengthen our protocol with regard to these 3 ethical principles. The first here is justice. So for that, we need to consider the selection of research subjects. So again, we're focused on school-age children in areas with high poverty, food insecurity, and undernutrition. And we have been asked multiple times now, why aren't we first studying golden rice in adults? But the driver of that decision, if we were to say, okay, let's do it in adults, the purpose of that would really be to circumvent any complications of working with children. So it's not ethically justifiable. At the same time, children are the group at risk of deficiency. They're the ones who would benefit from golden rice. So their inclusion as research subjects is justifiable. And in our case, we're focused on slightly older children, which again strengthens the ethics in this case. So finally, we're focusing on provinces where there may be early deployment of golden rice. So basically, those bearing the burdens of research are also the first to benefit from its findings. For beneficence, I spoke quite a bit of detail about the safety of golden rice. So, we can show an ethical review board that golden rice has been extensively reviewed by regulators in terms of its safety, in terms of its environmental impact, and so on. So from the perspective of ethical review boards, the concerns are more likely to center on things like the clinical assessment. So the retinol isotope dilution, things like food safety, or usual issues like privacy and confidentiality. And as I showed you, we've done trials like this previously, so we have clear protocols to mitigate those risks. For example, we've got extensive training and certification of cooks to ensure food safety. And in terms of benefits, there are immediate benefits to children and their families in that we would be providing school meals, but there are also broader benefits, especially in informing nutrition policy. In respect for persons, we generally think about the informed consent process, and a large part of our preparatory activities for this trial will involve building partnerships with communities. So we plan to involve community members in finalizing our study plans. They would also help us to develop appropriate language to describe the nature and the safety of golden rice to participating families. We plan to explicitly tell families that this is a crop developed using modern biotechnology. So we need to figure out how to communicate that to people in the community. So we plan to obtain written informed consent from parents, as well as assent from children, even though some of them will be somewhat younger than the age at which that's normally required. And at the time of the clinical assessment, we'd involve community members to also assure that there are no signs of children dissenting, as you might see when you have a blood draw for a child, that a child's really uncomfortable with that. And finally, families will have the right to refuse participation, and they'll be told that this will not affect their child's right to receive school meals. So we're really trying to think in great detail about these ethical principles and how we can strengthen the trial. Our study also will have careful oversight. We've already convened a technical advisory group of distinguished scientists in the Philippines, and they're guiding us as we start this research, and they'll continue to advise us throughout. We're also seeking ethical approvals from the Single Joint Ethics Review Board and the Johns Hopkins Institutional Review Board. We've had input as well from the regional ethics review boards in 2 parts of the country. And finally, we'd be working closely with the Department of Education, as this is a school feeding intervention, and with local government units, both in designing and in carrying out this evaluation. To give you a sense of our timeline, we plan to carry out our screening activities later this year, hopefully when children are resuming in-person classes. And the impact study would ideally take place in the latter part of 2023. So our analysis of biospecimens would be carried out in the first part of 2024, and we'd be prepared to widely share our results later that year. One last note that I want to make is about policy implications of our research. So the Philippine Plan of Action for Nutrition is the country's framework for nutrition improvement, and it lays out targets, directions, and priority actions, including for nutrition research. The Golden Rice Nutrition Evaluation has been included as part of the PPAN research agenda, specifically in the dietary supplementation thematic area. So we can be confident that our research is already in plans to inform policies about vitamin A deficiency control. To summarize my talk, we know that vitamin A deficiency remains a nutritional concern in the Philippines. The country has done a great job in implementing a diverse package of interventions, but there's still a need to improve dietary vitamin A intakes. As I showed you earlier, more than 60% of young children are not consuming sufficient amounts of vitamin A. golden rice has been proven safe for human consumption, and it offers potential nutritional benefits. So we feel that evaluating the nutritional impact of golden rice consumption will really be key. And again, this research is needed to inform policymakers as to whether and how golden rice may be considered as a deficiency control strategy going forward. There are a number of partners involved in the Golden Rice Project. As I mentioned, on the development side, work in the Philippines has been led by the Philippine Rice Research Institute, and they're working in collaboration with the International Rice Research Institute and other partners. I've included a QR code here for more information. On the assessment side of things, we are having an independent assessment of the product's development. This work is being led by Helen Keller International and our team at Johns Hopkins. We're also working with the Food and Nutrition Research Institute here in the Philippines, as well as collaborators at Newcastle University in the UK, who will actually be doing the stable isotope work. And funding for this work has been provided by the Bill and Melinda Gates Foundation, both on the development side and on the nutrition evaluation side. So in the conclusion, I'd like to thank the organizers once again. I've really enjoyed all of the activities in this webinar. I also want to thank the participants, and I want to note that people look to you as authorities in the field of nutrition or in crop science or as academics more broadly. And I hope that I've made a strong case here about the safety of golden rice and our extensive plans to evaluate the product. So I hope that you feel more equipped to field questions and to speak confidently in this area. We're also happy to speak with you further, and the organizers can assist in sharing my contact details or in putting you in touch with collaborators at the Phil Rice or at Erie. Now, I've gone a little bit quickly in my talk, so we have actually more time to answer questions. So I'm happy to speak about the nutrition side of things, or as much as I can about the development side. If there are issues that I can't answer, again, we'll provide the details for colleagues at Phil Rice in our supporting documents, and I'm going to switch back to that QR code for those of you who didn't have a chance to access it. So thank you again to the organizers, and I'm happy to take questions.
Okay, thank you very much for that lecture, Dr. Palmer, and it truly clarified a lot of points, like you've mentioned GMO safety, costs even. You've mentioned all of these factors that I think are very relevant right now in terms of promoting golden rice, because the Philippines has already approved the use of golden rice. So for questions, keep them coming. So the Q&A chat box is open. You can also raise your hand for questions. Don't forget to mention your name and affiliation for documentation purposes. So maybe I could start with the first question, Dr. Palmer. You've mentioned the denaturation by heat of express proteins. Is it safe to say that there are no significant losses when we cook? Because in the Philippines, we usually steam or boil rice. Right. So those two separate issues. So earlier I was talking about the proteins, the proteins that are novel in golden rice versus ordinary rice. So those are the ones that are denatured by heat. And we talk about that in terms of safety, right, when our comparison is to our ordinary rice. The other issue you're talking about is beta-carotene degradation, and there are some losses during cooking. But the majority of losses that we see in the carotenoid degradation is in the storage period. And there's work going on now to figure out how we can mitigate that if there's some kind of packaging that could be used to reduce those losses. But I should know, I didn't mention this earlier, that we plan to evaluate the golden rice after that 2-month storage period. So I mentioned the concentration about 4 to 6 micrograms per gram. That's what we'll be using in the trial itself, because we want to mimic usual real life conditions and how people would be consuming the rice, again, under normal conditions. So thank you very much for that clarification, because that's very useful for us, especially when we promote this one in the households and we really want to maximize the vitamin A content of the biofortified grains. In relation to that, we have another question here. Maybe you can give us some recommendations on how to promote this one to families, like, based on your experience. I know that you have talked to a lot of stakeholders, because you know that in the Philippines also, we are very used to polished white rice.
Right.
Now, introducing a yellow, should I say, it's not a variety, but an alternative. How do we promote this one to families, to households?
Right, right. So my understanding, I'm new to the Philippines, but my understanding is that there are different colored rices or rice dishes that are consumed here. So that's not a completely foreign concept. And if we can get the public to be confident in the modern biotechnology and not be frightened off by the issue that it's a GMO crop, I think what we see with the other biofortified crops is we can speak to this being a vitamin A crop. It's better for nutrition, and that's really valuable to families and supporting their children. And in my experience here, I would think, because of the widespread, supplementation campaigns or fortified food products, is that people know about vitamin A and they know that it's important for their children's health. And that is a very powerful message that I think we'd be relying on in the promotion of golden rice.
Thank you. Yes, that would truly help us in making our messages richer, in terms of, because yes, everybody is familiar with vitamin A, and we've been teaching our pupils in primary school of the importance of vitamin A for eyesight, for immunity.
Right.
We have another question here in the Q&A box from Raniel Monton. Are there any chance that golden rice will crossbreed with other common varieties, producing unexpected hybrid species of rice?
Right, right. That's certainly a concern that's been raised by a number of people. And there's a few responses to that. One is that if plants are separated, if you're planting golden rice and a conventional rice just a few feet or a few meters apart, there are very limited chances, or there's cross-pollination would be rare. So that's one point. And to expand on that, it's unlikely that the two would be flowering at the same time. So the chances again of cross-pollination would be unlikely. And the final part is, fine on it. The rice pollen is normally viable for only a few minutes. So if the varieties are two different places separated by a minimal amount of space, they're flowering at different times, and the pollen is only active for a short period of time, there's really very minimal chance of cross-pollination.
From Lizelle Atienza, in addition to the improved vitamin A rice, what else are the nutritional advantages of the golden rice over the conventional ones?
Right. So the specific development of golden rice was to address vitamin A deficiency, and all of the efforts went into those enzymes that could produce beta carotene in the brain. So at this point, golden rice is specific to addressing vitamin A deficiency. But there's a broader healthier rice program that has the goal of having not just beta carotene, but also introducing zinc and iron to rice, so that it could be kind of a package of important micronutrients. But that's a longer term goal.
From Flerida Carino, how will the study factor in the other sources of carotenoids in the children's diet? Because you've mentioned that your study was among children, especially for food provided outside school.
Right. So that's not something that we can control. What our goal is to get as much rice into the children in the feeding program. So, we know that usual rice intakes in children are around 200 grams dry weight per day. And that is what we'd be giving in the 2 meals that we would be providing. So we can't control what they're consuming outside of the feeding program. But again, this is a randomized controlled trial. So we'd assume that behavior would be equivalent across the 3 groups. And the other thing that we would do is, I mentioned the 24-hour recalls, the repeated recalls, so we can measure what they're consuming outside of the context of the trial. But, the goal is generally to control to the extent possible what they're consuming. And a big part of that is providing a large portion of their daily requirements through the meals provided by the study.
And I think it's I can already connect the next question here from Marisa Romero. What do you think will be the greatest challenge in the conduct of your bioefficacy study?
Yeah, so normally for a feeding trial, I would say logistics. But in this particular case, I think it's going to be perceptions within the community of GMO crops, which we can hopefully begin to address as soon as we identify a community where we would be carrying out the trial. And we have numerous plans to do that. But this trial can get the attention of external folks as well. And we know there are active opponents of GMOs in the Philippines, and even in a broader context where we really want to assure communities, assure the public that this is a safe crop. And I should mention once again, that's one of the reasons we wanted to do this webinar is we're going to rely on people like you, on people in this audience to be confident in educating others about the safety of the crop. Because I suspect that, aside from logistics, a lot of it's going to be the perception of, you're feeding a genetically modified crop, you're feeding it to children, you're treating our children like guinea pigs, those types of questions. So, I wanted to talk about the ethical aspects of the trial at the latter part of my talk, because we take those questions very seriously, and we need to come up with good responses to them. And I hope that's what we're in the process of doing, but we're going to need to do that very much so in the communities themselves.
So yes, I would resonate with that really the consumption is one key factor. Like we've already heard the first part of like having mandates regarding golden rice, but having people to actually consume it is one big challenge that relies on us. So education is really key. So thank you very much for that. So it is said that so this is from Yolda Abante. So it is said that vitamin A must be ingested in small amounts. So you mentioned before about toxicity, and maybe you can give us more insight, since rice is a staple food for Filipinos. One can get an overdose if taken regularly.
Right, so this question comes up a lot. So yes, vitamin A is a micronutrient, meaning that we need it in small amounts. That doesn't necessarily mean that we can't consume it in larger amounts, right? And specifically for the provitamin A carotenoids, there's really, if you're consuming them within a normal diet, you can't get too much of the provitamin A carotenoids. If you do, the worst that can happen is that you would have that yellow to orange pigmentation, which, like I said, is a benign condition, and it's a reversible condition. And there's some evidence that you also would need a genetic mutation in that BCO1 enzyme that cleaves beta carotene. So at dietary intake levels, it is a safe nutrient to consume. And even if you consume a lot of golden rice, even very, very high consumption of golden rice, that would not be an issue. And because this is partially a nutrition audience, some of you may be familiar with the chronic disease prevention trials that used beta carotene and in some cases other nutrients. And those sometimes come up, when we talk about concerns of high doses of beta carotene, where in some, not subsamples, but in some subset of participants, so smokers, for instance, the beta carotene supplements seem to increase risk of mortality. And there was a lot of attention to those trials and a lot of concern about beta carotene. But honestly, those trials were providing really high dose supplements. We're talking more than 10 times what you would see in a normal diet. So golden rice cannot provide that amount of beta carotene that we would ever be concerned about, high risk of beta carotene toxicity, if that is even the case. So those were, possibilities of why we might have seen differences in the trials. That's not kind of set in stone. There were other studies that did not show that. So that's beta carotene. Vitamin A is separate. There, you can have too much vitamin A. It can affect the liver, it can affect bone health. That is, vitamin A toxicity exists. But really where we've seen it, if we see acute vitamin A toxicity, it's generally people who overdose on supplements. And I'm not talking about supplements that are given every 4 to 6 months. I'm talking about people who take a multivitamin or take too much of a multivitamin. So toxicity exists, but it's only preformed sources of vitamin A, because if you're getting a lot of beta carotene, even if, again, you're eating a huge amount of golden rice, you're not going to convert that. If you have adequate vitamin A status, that's going to stay in the body as beta carotene. So there's no risk of vitamin A toxicity due to beta carotene consumption. So that question comes up a lot, and I hope, and I was speaking really quickly there, but I hope that this audience now is confident that toxicity from a nutrient perspective is not an issue. Beta carotene consumption is safe. It's not going to affect vitamin A status to the level of toxicity. And honestly, I should mention as well, because there are numerous interventions in the Philippines to address vitamin A deficiency, but we're talking really excessive amounts. So not a huge public health concern at this point.
Okay, so thank you for keeping on emphasizing the difference between beta carotene and vitamin A.
Mm-hmm.
Really talking about two different substances here. Now, we have another question from Henry Dupo. What is the eating quality of golden rice compared to popular rice varieties? Like he gave examples like RC216 and RC218. So
yeah. So eating quality, or I'm not sure I got that. So the testing that's been done shows that there are no differences in taste and texture, in the aroma of the rice that are discernible between, golden rice versus ordinary rice. So the only difference there is the color. And again, it's because beta carotene is a natural pigment that you get that golden color. I'm trying to think of what else would be involved in. Is what you said, eating quality, right?
Eating quality. Mm-hmm.
Yeah, I think those would be the major issues, other than people's perceptions. So I remember in Africa there was there's such a strong preference for white maize, just because it's what people are used to. That convincing people that orange maize is not a negative. It's almost like people think that it tastes different because they have that concern about color. But again, I would rely on being able to market this, and just on the market, but to educate folks that really the difference here is the nutrient profile, and that there is a potential health benefit. Well, that's what we're going to be testing, right? That's our hypothesis, is that there's a potential health benefit here that hopefully will overcome those concerns.
Okay, so let me just echo this one because the question was from our Facebook platform. Okay. So this is Marisa Romero says introgression was made to common popular varieties, so the eating quality is just the same as the background variety. If that would what
thank you, Marisa.
we're discussing right now. Yes, and we have another question from Riaz Awais. PhD scholar, Arkansas, USA. My question is that with the insertion of vitamin A genes, will it disturb other biochemical processes?
Right. So we saw there were differences in 3 genes. So 2 of them are involved in the beta carotene biosynthesis, or the carotene biosynthesis pathway. That is where their action is. Their action is in generating beta carotene. There's no reason to believe that they would act anywhere else. And the PMI gene, that's commonly used in transgenic methods. And again, these are very targeted to the specific biochemical process. There's as far as I know, no reason to believe that it would have any effect elsewhere.
We're talking of combining here golden rice and white rice from Claire Delmo. So what would be some possible effects on potency, perhaps?
Right. So that's a very good question, because we can't guarantee that we'll, even once golden rice is available, that it would be completely replacing white rice. So, it's possible you'd get especially children, that maybe they have school meals that are based on golden rice, but at home they're getting white rice. So you wouldn't see that 100% replacement. In that case, it would be a dilution of the effect of golden rice. So you wouldn't be getting the same dose of beta carotene, if you will. So I think we can't fully answer that question until we do the trial, at which point we know what the nutritional impact would be. But theoretically or hypothetically, it would dilute any effect that is present. And that's something that we would be able to model out once we have the results of the trial.
And maybe you might want also to respond to this common question: why the need for golden rice when we have a lot of vegetables that contain carotenoids?
Right, I hear that question a lot, and I completely understand why that's out there, because there are. I mean, I went to the market the other day and was looking at all, especially the dark green leafy vegetables. There are quite a number of them, but I would think back to the slide that I showed all of the cups of kangkong, and I mentioned it earlier when I talked about why vitamin A deficiency exists. So for small kids, infants, who are being introduced to complementary foods, you would need to eat such a quantity of dark green leafy vegetables that it's physically impossible for infants and young children to do that because of the size of their stomachs. Because you have to think about that bioaccessibility, the ability to break carotenoids out of the food matrix is much more complex in dark green leafy vegetables. The bioavailability, you might necessarily absorb as much, and the bioconversion, that whole process of vitamin A equivalency, it's not as efficient for dark green leafy vegetables. And when you think about it, some of them are seasonal, so you're not going to get them year-round, things like mangoes. So that's something to consider. And another one is they're not always things that you eat every day, and certainly in large enough amounts to be comparable, whereas children are eating rice. It's a major component of their dietary intakes. They're eating that on a regular basis. So there's a real potential to benefit there. But I should stress that our goal is dietary diversification. So we need all of these various things working together. And the focus is not completely on vitamin A. We need those dark green leafy vegetables or yellow and orange fruits for other purposes, fiber, for instance, or any number of micronutrients. So our goal is to have a diverse diet so we can get the benefits of all of these foods.
Yes. So I've noted that down, diversity in the diet. So we are not really, ruling out or lessening the intake for other types of food when we eat in golden rice or when we choose to eat golden rice. It's just a matter of balance. And I've also noticed that bulk. So you've mentioned the bulk of the vegetables. Could a child eat a cup, half a cup, 2 cups, in order
12 cups
in order to meet the requirements for the
or to have a comparable amount of beta carotene intake. Right.
And we know that you've been having some discussions with stakeholders, because you've mentioned like impact evaluations and interviews, perhaps. We have a question here. Have orientations been made? Would you be aware of any orientations made with local government units, perhaps, and other agencies?
Right. So, the development of golden rice has been going on for a long time now, and planning for the deployment is going on with colleagues at Bill Rice, with colleagues at the International Rice Research Institute. So they've done quite a bit of work in sensitization, in working with, the Department of Agriculture, which has very strong support from Secretary Dar. They've been working on educating people, educating farmers, and that's going to be a continued focus of their deployment plan. For us on the nutrition evaluation side, that work has really just begun, but we've developed our technical advisory group. We've had meetings with, the National Nutrition Council is involved, the Department of Education is involved, a number of different agencies, and we're continuing that now at a provincial level. And as we start to focus in on specific provinces and specific LGUs, that will be a next step as we move forward with our screening study. But yes, we're actually going to NDK next week to try to meet with as many people as we can, not just to educate them about golden rice, but to hear their concerns about, GMOs in general, about doing a nutrition study, about blood draws of children. So there's a lot of work going on, and I should stress once again, the deployment side, the development side is independent of the evaluation side. And at this point, the role of Keller International, Johns Hopkins, and FNRI is really to evaluate it. We're not at the point that we would be involved in promoting it. That would be a separate step.
So thank you for that clarification. Now we have another question here from Carl Dapula of Erie.
Mm-hmm.
Have you tried rice transformation using CRISPR or CRISPR technology?
Right, the CRISPR technology. So I'm not sure about rice. There have been biofortification efforts, and if I were to go back to the carotenoid biosynthesis pathway, there have been efforts using CRISPR to edit that particular pathway. I'm not sure if CRISPR is being used in rice. That would actually be an Erie question or a Phil Rice question. So I'm going to send it back to the Erie folks to answer that.
Okay.
It's been, sorry, I think it was in banana. It has been used for vitamin A biofortification, but I'm not sure about work in rice, whether vitamin A or any other nutrient.
Mm-hmm. Let me echo this one from Carl Vincent Cabanilla. Congratulations on your excellent presentation, Dr. Amanda. You were able to explain a complex topic in very simple terms. I find your slide on the relationship of various inflammation markers with serum retinol levels very interesting. Do you think the VAD prevalence data would have been different if we have a better idea on the incidence of inflammation among the population?
That is really an excellent question. And the answer right now is that we don't know. We don't have, the National Nutrition Survey at this point does not include inflammatory biomarkers. That's something that our study will be adding. In our screening study, we should be able to start to address that question. But working in Africa for a number of years, you would see inflammation, especially with CRP, like that acute phase of inflammation. In that case, I can say confidently it really does affect the prevalence of deficiency. But my experience in Asia, I'm new to Southeast Asia, but working in South Asia, it's not really CRP that we see elevated, it's AGP, and that doesn't necessarily have the same impact on what we see in terms of serum retinol concentrations. But really the answer, it's a great question. The answer at this point is that we don't know. It's possible. Or it's possible that, in the Philippines, what we see as vitamin A deficiency really is more driven by diet. And that's what I would suspect just based on the dietary data and the prevalence of inadequacy. But we need to test that, and that's what we plan to do.
And another one from Irene Agustin Arnejo. Thank you for your lecture, Dr. Palmer. Golden rice indeed show promise in addressing the vitamin A deficiency in the country. My question is, shifting to the agricultural sector. So will there be an impact of golden rice in the agricultural sector? I am raising this because I think majority of the hesitation will stem from the agricultural sector, which may contribute to lower consumption preference.
Right. That is another good question, and I don't have a great answer for that. Not being on that side of things, not working on the deployment side. Again, there's going to be quite a bit of work on the deployment side by Phil Rice in educating folks in that sector. And I hope they'll be able to rely on the results of our research in talking about this as a potential strategy really to improve nutrition. I think a big part of the hesitancy on that side is going to be GMO in general, and it's going to be the questions about cost and about cultivation practices and about yield. But there are good data on that now, and if we can educate farmers that they're really the only difference is in the beta carotene content, I'm hoping that would help to overcome concerns. But yeah, I think that's going to be that's going to be the next several years of work on the part of Phil Rice and their collaborators, is that sensitization. And honestly, right now, golden rice just got approval for commercial propagation. So a huge part of the effort over the next few years is going to be bulking up seed to the point that actually can go out on the market and get out to a lot of farmers. I think in the next 2 years, the focus is going to be on really targeted deployment to those high vitamin A deficiency areas, both in providing seed and providing milled rice, but at a smaller scale. So they'll be ramping up those activities. And I see that Ronan just posted something. Oh, he's talking about the golden rice trait's been interbreast into popular high-yielding varieties, so farmers should be familiar with those.
Yes, because we're already towards the agriculture sector, let me just interject this question from earlier. Do fertilizers have effects on levels of vitamin A or the environment, perhaps, conditions of the environment?
Yeah, so I really can't answer that question other than to say that, again, cultivation practices, use of fertilizers should not be any different for golden rice versus conventional rice. But I don't know the answer to whether fertilizers would have any effect on carotenoid content. I would have to turn that over to Phil Rice folks or folks at Erie.
And maybe perhaps the soil quality, because I think farmers would have different conditions depending where they are.
Right, exactly. The soil quality, that can really affect mineral content, but I don't know why it would have an impact on carotenoid content. But again, that's not my area of expertise.
Okay, so a follow-up question here. For your study, are you also going to grow the golden rice in the study site for the feeding program to increase acceptance?
To increase acceptance. Well, in terms of the rice that we would be using in the trial, that is going to be grown by Phil Rice in one of the areas where they are growing the golden rice. So it's going to partially depend on where we choose to do, not where we choose to do the study, but where we decide to do the study based on vitamin A deficiency prevalence. So it's possible that we will find an area that is not currently targeted for deployment. Our goal is to find a deployment area, but it's possible in that case that we would have to bring in the rice from outside the province. But I would hope that we would have some overlap with deployment, because I think that farmers can be real advocates as well, for biofortification studies, and building that support within a community would be really helpful, and vice versa. Our work in the trial will hopefully help farmers in the community think, okay, I know this, I'm familiar with it, it doesn't scare me. I feel like after the trial is done, I want to adopt it. So it kind of works both ways.
Okay. I think we have another common question here, voiced out by Maye Angeline Belinario from West Visayas State University. If golden rice will be commercially available, will it be more expensive compared to other rice varieties that is presently available in the market? I think cost is another important consideration.
Right, that question comes up a lot, and the production costs will not be different, because again, it was introgressed into common varieties. The PSBR C82 that is already commonly used in the Philippines, or a popular variety with farmers. So the cost of production, any of the inputs like fertilizer really would not have any effect on cost. I just saw a note from the field trial areas. I shouldn't try to follow the chat at the same time as answering questions.
Yes, so this is from another participant. We have not observed significant difference in carotenoid content of golden rice in our different field trial areas. The same observation in our Bangladesh field trials.
Okay.
We have going back to the study. Okay, because we have a question here that just came up. I seem to miss how the children in school will be allocated in 3 treatment groups.
Right.
In the case it is by individual randomization to 3 groups in each area? Do you think the yellow color of golden rice will affect compliance, and how the study plans to address it?
Right, so that wasn't missed. That was something I didn't talk about. So it would be an individually randomized trial, and it's not going to be blinded, right? But if we look at the golden rice, it's not as dramatically different in color as we've seen previously with kind of previous iterations of golden rice. So there is a possibility it would affect compliance, but I really don't know. I mean, we didn't see that working with the orange maize. These are children, and they're hungry children, and if we give them food with a good side dish to go along with the rice, they will eat it. So I don't have a great answer to that, but it's individually randomized. They would be in the same classroom with their peers who may be consuming a different rice, but I'm not entirely sure how it affects compliance, but we haven't seen that previously in our studies with children. They're pretty compliant and aren't necessarily that concerned about what their peers are eating. At the same time, we'd also have oversight, because I don't know if it would be teachers. This is something we're still working out, who's actually going to be in the room when children are eating. But we have that kind of oversight of feeding, because people often ask about sharing, for example. How do we control sharing between children? And that, again, is something we haven't seen to be an issue when we have either folks who are working on the study who are employed by Helen Keller International, or if we have teachers there or other community members, we don't see sharing, or we don't expect sharing to be an issue.
Okay, I think this would supplement our previous discussion. I would like to echo Swami Malikaruhuna. Carotenoid expression is stable, and agronomic other traits performance is similar to the respective popular rice varieties, and cost of production is same as any other rice variety. So
thank you, Dr. Swami.
Yes, so thank you very much, everyone, for keeping the ball rolling. Like, we have a lot of comments and questions here, but unfortunately, okay. Can we have more, like, last 2 questions maybe?
Yeah, absolutely.
Okay. Why is the bioequivalence factor of GR different from other plant sources of beta carotene?
Yeah, so it has to do particularly with that bioaccessibility. Just the food matrix is not as complex in rice or most of the biofortified crops versus dark green leafy vegetables. It's just easier to access the carotenoids in order to absorb them and in order to bioconvert. But that, again, that vitamin A equivalency, those data are from, actually, vitamin A equivalency includes all of these things. It's the bioaccessibility, it's the bioavailability, and it's the bioconversion. So I had that, that slide with the 4 pictures across looked at the dark green leafy vegetables and whether you're consuming it with fat in the diet, or whether you have an intestinal helminth infection, or whether you have a genetic polymorphism. There are a number of factors that affect that vitamin A equivalency. And the data that we have right now are from adult volunteers in the United States. And that's part of what we'll be measuring in the trial with the 3-arm design, is to be able to get a good measure of vitamin A equivalency in the target population. And that will be, in and of itself, that would be a contribution to the literature and to better understanding golden rice and how it can have an impact.
And maybe we could end this with this last question. So thank you very much for an informative presentation, Dr. Palmer. So this is Adrian Gandesila. I'm Adrian Gandesila, a UPLB graduate student in botany, minor in MBB. I may miss this during the lecture, but may I ask on how researchers will clear or address hesitations by the parents and or the students themselves on taking the golden rice? Maybe you can share with us key messages.
Right.
I think this is the best way to conclude our lecture for today, because we're
Right.
going back to our respective offices and bringing with us valuable information. But most importantly, we need to communicate this one to our friends and family. So maybe you can give us some key messages that we could share with parents and even students.
Yeah, I think that is the most difficult question. So it's great you left that one for last. I don't have a terrific answer at this point, except in the context of the trial. We really need, as soon as we identify a site, we need to be on the ground and working with community members and identifying champions and training them, even on basic biotechnology 101, so that they understand what is a GMO. Is it something I need to be afraid of? If not, why not? And communicating that to influential people in the community, so that information can be then communicated on to parents. And I mentioned that, in the ethics space, that community members are really going to have a role in this trial. We see them as partners, and we really hope that they'll be able to help in the sensitization and even in developing language to explain in a consent statement that this is GMO and what does that mean? Because we want to be very open with the parents and with participants. But we just started, so Phil Rice and Erie have been working on messaging for several years now, but it's from the nutrition efficacy trial, the nutrition evaluation side. We are just starting up that work, and we have some sense of the questions that will come up, but it's a complex study in an area that probably has not had researchers coming in and randomizing people. So we're going to just be starting to write down the questions that we're hearing and really to come up with good answers to those. And we've just brought on a communications specialist who can help us to better communicate, especially complex scientific, issues, to really be open with the community and to do our best to communicate and give accurate information. But yes, that is a big challenge. So it's a good question to end on. And hopefully if I come back, I'll have a stronger answer to that question.
So thank you once again. I think at this point, we're now ready to award our certificate of appreciation. Thank you very much, Dr. Palmer, for spending your whole afternoon with us. So may I request our Dean, Dr. Ricardo Sandalo, and our Institute Director, Dr. Amy Sherry Barrion, to join Dr. Palmer on screen. So I think they're already here. Hi, Dean. Hi, Ma'am Amy, Doc Amy. Hello. With much gratitude and appreciation, we are presenting to you the Certificate of Appreciation, Dr. Amanda C. Palmer, in grateful recognition for your invaluable time and expertise as our resource person on the topic is their gold in golden rice. So addressing vitamin A deficiency through biofortification, held on the 23rd of March 2022. Given this 23rd day of March at the University of the Philippines, Los Baños. So signed by our director, hi Ma'am Amy, and our dean, hi Dr. Ricky. So they're both here. So thank you very much, Dr. Palmer.
Thank you as well. This has been a great opportunity to reach a wide audience, and hopefully we can count on you as being champions of golden rice as well going forward.
So, Dr. Palmer, once again, thank you. Thank you very much for gracing us with your presence this afternoon. I think Dr. Palmer is actually in the Philippines, so I hope you're having a good time right now.
I really am. It's been wonderful.
Thank you very much. All right.
Thank you so much.
So everyone gets to receive a certificate as well. So make sure to fill out the evaluation form that will be sent after the closing remarks. Also, the link for the IEC material. So you'll be receiving some aids there, materials via email with your certificate. So Dr. Palmer's lecture will also be available in the ITNF YouTube official account. So to formally close our program, let us welcome the Director of the Institute of Human Nutrition and Food, College of Human Ecology, Dr. Amy Sherry A. Barrion, to deliver her closing remarks.
Thank you, Ma'am Ana. So a pleasant good afternoon to everyone. So for the majority of Filipinos still, a meal is incomplete without rice. So rice provides the daily caloric and nutritional needs of many Filipinos. So given this, the nutritional value of it can be reinforced during production to address the prevailing malnutrition problems such as micronutrient deficiency. So various programs and policies have been implemented by the Philippine government in the past to alleviate this nutrition health concern. And the process of biofortification was introduced to improve the value of rice in terms of nutrition. So in the past, in the 1990s, the prevalence of vitamin A deficiency among children ages 1 to 5 years of age was quite high. Imagine, ranging from 35 to 38%. And as mentioned earlier, the results of the recent 2018-2019 expanded National Nutrition Survey of the Department of Science, Technology, Food Nutrition Research Institute reported that 1 out of 6, or 15.5% of Filipino infants and children under 5 years of age are the most affected population in terms of vitamin A deficiency. Actually, the children in rural areas have slightly higher vitamin A deficiency prevalence than those in urban areas. So this lecture is very timely, a review of the development of golden rice and the potential of this innovation to address dietary inadequacies and its impact challenges in terms of consumption, utilization, and research. So we were really very eager to hear what's happening in the field. What's the latest on golden rice and where is it going in the future? So again, I would like to also very much thank Dr. Amanda Palmer for gracing us. I hope you can visit us in the future, ma'am. You can visit our university. You're very much welcome. So welcome, ma'am, to University of the Philippines, Los Baños. So we hope we can see each other personally. And I would like to also thank HKI for working with us, Ma'am Glyza Calayo Garbiles, Ma'am Maria Fatima Riario, and Dr. Rolf Clem. Thank you so much, sir. And also, I would like to acknowledge the IHNF organizing team led by Ma'am Rodessa Forcadilla. So once again, Dr. Amanda Palmer, thank you so much, especially highlighting the safety profile of golden rice and stressing the importance of increasing the dietary intake of vitamin E. So once again, good afternoon and thank you, everyone. Back to you, Ma'am Ana.
So yes, so thank you very much, Dr. Barrion. So if you can spare me 2 more minutes. So on behalf of the organizers, the Institute of Human Nutrition and Food, UPLB, Helen Keller International, and Johns Hopkins Bloomberg School of Public Health, we again thank you for spending the afternoon with us. Stay safe, everyone. The link is already in the chat box. So thank you very much and have a good day.